All right, so in the previous video, I went ahead and solved this portion of the superposition problem, which is the equivalent circuit where the voltage source is shorted, right? No voltage source in this circuit. In this circuit, I'm going to solve for the current source being open, right? There's no current source there, okay? And so we're going to go ahead and solve this circuit. Let's start by looking at VZ2. Okay, this is an interesting concept here, but it's pretty straightforward once you kind of understand what's going on here. In order for a current to flow, it needs a loop. Okay, there's a loop here, but there's an open circuit, so no current can flow into this branch of the circuit, which basically means no current can flow out of that branch of the circuit as well. So the 2K resistor is going to have no current through it. Okay, well, if that's the case, and I know that this side is at 0 volts because it's connected to ground, that means VZ2 is also going to be equal to 0 volts. Why is that? Well, that's because the voltage drop across my resistor is equal to I times R. And if I is 0, then that drop also needs to be 0. So the voltage on either side of my resistor is going to be the same, okay? In this case, it just happens to be ground. I'll just leave this here. I got rid of it, but I don't need to get rid of it. It happens to be ground on the bottom, so it's going to be 0 volts on the top as well. Okay, so VZ2 is done. We've got that at 0 volts. Okay, so right now we could already go ahead and plug in values for VZ1 and VZ2, but let's just leave that for the end of the problem. Okay, we also know VX2, which is just straightforward. It's a voltage source. I've got 0 volts on the minus side, which means that the plus side is going to be 10 volts because that's the rating of my voltage source, right? So I've found VX2, I found VZ2, now I just need to find VY2. And it may not be obvious to you yet, but it will become more obvious. The reason why this is the case is because no current can flow here, but this is just a voltage divider. I can just treat this circuit as just the singular voltage divider because no current can flow here. So the rest of the circuit, this can basically just get kind of thrown out. We have 0 volts here, we got 0 volts here. Might as well just be ground here and we can forget about everything else. So we're really just looking at this portion of the circuit to solve for VY2 because this current is going to be the same as that current. So it's basically as if I didn't even have this here, basically just disconnected. Okay, so let's go ahead and solve that voltage divider. We know that our voltage divider tells us VY2 is equal to 10 volts, right? The voltage here, multiplied by the second resistor, divided by the sum of the two resistors, okay? So basically 8 divided by 9 times 10 gives me 8.889 volts. All right, and that is my VY2, okay? So I've got VZ2 here. Oops, let me get my box tool. VZ2 is there. VX2 is there. And VY2 is here. And so now what we can do is we can go ahead and plug in these values into these sums to get our final values. So let's go ahead and do that. So let me just start erasing stuff. VX2 is 10 volts. VX1 was 0 volts, okay? So that means that VX is 10 volts. I'm done with VX. VY, let's look at VY. So VY1 was negative 1.778 volts. Negative 1.778, and then VY2 is 8.889. So let's go ahead and add those. And I get 7.11 volts for VY. So that we'll check that one off. We're done with VY. And for VZ, we've got 0 for the second case. So that's going to be 0. And VZ1 was 4 volts. So that means that VZ is equal to 4 volts. Okay, so we found all the voltages in the circuit, and we can go back now and basically say that our original circuit that we drew, these are my voltages right here. Let me struggling here, sorry. Copy this, and then we go back to our original circuit, paste and make it a little smaller, and these are the voltages. Vx is 10, which we can see by inspection from the beginning of the problem. Vz is 4, which we can also see by inspection from the beginning of the problem. If we analyze 2 milliamps times 2K gives me a 4 volt drop. We know this is ground, so that makes sense. And then Vy, you know, you could solve using nodal analysis if you really wanted to prove it to yourself, but superposition tells us that Vy is 7.11 volts. Okay, so we are done with this problem. We solved it using superposition, and I hope that this all makes sense. Obviously, if we have any questions, feel free to ask. In the next video, we're going to go ahead and move on to mesh analysis.